Okay, let us now build a queue using linked list. In this tutorial, I'll show you how we can build a queue using the existing operations of the linked list. We have built the add last, that means insertion at the tail operation, in our earlier tutorials, and also we have seen how the delete first works, and we can use these two operations in order to just implement the insert and delete operation for a queue when we use the linked list as the data structure for the queue. Okay, and the tail is going to act as the rear marker of the queue, and the head is going to act as the front marker for the queue when we build the queue using linked list. So we'll be always adding the new node at the end of the linked list, and we'll be deleting the node from the head of the linked list. So the insert at tail is going to be the insert operation for the queue, and delete from head is going to be the delete operation for the queue. So let us just use these operations and build the linked list. But before that, I'll just like to elaborate how this idea is going to work. So at the very beginning, the queue will be empty. So we have the head and tail both as null. And if we call the insert at tail operation, then obviously the new node will be created. That's our first node, and head and tail both are going to point to this node, right? And we do not have anything else. Now, if we call the insert at tail operation once more, then the new node will be added at the end of the linked list. That's what we want for building the queue. So it's going to be here. Say the data is 20, so the new node is added at the end of the linked list. Now, if we call once more, then obviously the new node is going to be added as the last node, that is the third node for this example. So here we go. So tail is pointing to this 30. Now, if we want to delete a node, and if it is going to behave like a queue, then obviously we are going to delete the first one. That's the first inserted node, so that has to be deleted first. So we'll call the delete first operation. That will delete the first node always. So this will be deleted, and the head pointer will be moved to the second node. Delete first operation will do the needful for doing this. And again, if we call the delete first operation, then this 20 will be deleted. So you see, we can use the delete first operation for implementing the delete operation for queue, and insert at tail for implementing the insert operation for the queue. That's how we built the queue using linked list. So let's go ahead and see the program. I have already copied all those code from the previous program to this one, and I have created this file linkedqueue.c, as you can see. So this is the implementation of queue using linked list, and we have the same structure for node and the linked list, and we have these operations. Insert at tail, that's going to act as the insert operation for the queue, and this delete first, this is going to act as the delete operation for the queue. So I'm changing the name. I can just change to delete queue and insert queue. They will be much more appropriate. Okay, so the init list is going to initialize the linked list. Both head and tail are going to be assigned with null and node count 0. That is as usual. So this insert at tail, that is going to be changed to insert queue, and the code is just same. I have described and explained this code earlier in the linked list tutorial. So I hope that you understand this code very much well, how that works. If not, then just get back to the linked list tutorial and go through that particular lecture. Okay, so the print list is going to print the linked list, and delete first, this is going to be delete queue for this particular program, and that's going to delete the first node of the linked list, and that's what we want for our queue. And after deleting it, is going to free the node as usual. So we have this menu operation, insert, delete, and display, and then obviously we are having that while not quit loop that's going to iterate and will ask for the operations from the user. Now, so if the user wants to insert into the queue, then case 1 will be executed. It will get the value from the console, and it will make a call to the insert queue operation, and it will pass the address of the queue. You can see that I have declared this linked list object as queue here. Earlier while we implemented the stack, it was actually linked list stack. Now this is linked list queue. So we are passing the address of the queue here in the insert queue operation, and when the user wants to delete, we will actually call the delete queue operation, that is going to delete the first node, and we'll get back the data as the return value. So if that is minus 999, the queue is underflow, otherwise it's not. So we'll be printing the data. So let's go ahead and run this program. I will be using the terminal for this purpose. Okay, here we go. Let me just compile. The name of the file is linkqueue.c, and I will attach this file after this tutorial. Okay, you'll get this code there with this lecture. So that is compiled successfully and I'm running that program. So here is the menu. If I choose 2, it will get me queue underflow. Yes, that it is. And if I try to insert some values there, 100 has been inserted, again inserting 200, then again 300. Now if I call the display operation, it's going to display the linked list. Okay, that's it. Now if I call the delete operation, I mean operation 2, then 100 is deleted first. It's queue, so 100 is going to be deleted first, right? Because that was inserted first. So first in, first out is happening. We can see that 100, 200, and then 300 has been deleted. Now if I call the delete operation once more, it's queue underflow. So that's how this is working, and that's how we can build a queue using linked list. Okay, next is a new section where I'm going to introduce a new data structure, doubly linked list. It's a linked list, but each node of the doubly linked list contains 2 pointers instead of 1 pointer. Now 1 pointer is going to hold the address of the immediate next node, that is as usual, just like the singly linked list, but the other one, that's going to hold the address of the immediate previous node. So from each node, we'll be able to traverse in either direction that we were not been able to do in case of singly linked list. So that's the facility of having doubly linked list, and we'll see how we can implement that doubly linked list and various operations on doubly linked list in the next section. So thank you very much for watching.